Cool here. I'll do a video. Got you at spaceweather.com, but before we dive into the information, I just want to talk about right here. I got a subscriber left a comment, GT from Yah, GT for Yah. Okay, I'm assuming that means Yahweh or Yeshua or whatever. You want to use names you want to put there. I think that's what that's trying to say. I'm not sure if it's a woman or a man. They didn't specify, but they homeschool their child, and he's in the 7th grade, and his name's Johnny, and they're from Montana. And they say they like watching my videos and stuff, and I think it's really cool. That's the kind of stuff that keeps me going, guys, and I do appreciate those comments, and it really does. It picks me up. So thank you, Johnny, for watching. Just want to say what's up, and everybody else that's here, take a couple seconds, throw a comment down there, and say, hey, what's up, Johnny? So Johnny from Montana. Anyway, okay, we're going to go into this information. This is spaceweather.com, guys. First thing we're going to talk about is the cosmic ray thing. Okay, they're intensifying. They're saying right now it's 1.6% away from setting a space age record. Okay, what does that mean? Okay, to me, I'm hearing that phrase, setting a record, very, very often lately, across the board on any kind of subject we talk about. Okay, I think that's significant because that's telling you that things are ramping up when you start seeing those things just continue and continue across different subject matter. It's always talking about setting records. Things are at their high, okay, except for the sun. And this cosmic ray right here, this is why the cosmic rays are getting through. When the sun's in a solar minimum, its shields are weaker, all right? It stretches out and protects our solar system from cosmic rays. Cosmic rays can come from any direction. So when the sun's shields are down a little bit, or even a lot, more of these cosmic rays get through. It's just like how our shield protects us from the sun. So when the sun's weak like that, these cosmic rays start hitting us more. And they issue warnings, guys, for these guys, especially air travelers. You know, pregnant women that travel a lot, especially in higher latitudes, you gotta pay attention. Closer to the North Pole, the cosmic rays are more intense there. They're not more intense, I shouldn't say. They get through more. Okay, the shields aren't blocking it as much up there. All right. So as you get down closer to the equator, it's more stable or strong, I guess. Our shields are stronger there. Sorry about that loss of couldn't find the word there for a second. But yeah. So you can, you know, pregnant women, pilots, stewardess, stuff like that, frequent flyers that are up in higher latitudes, pay attention, guys, because this can cause a lot of issues, get you sick. Okay, so the next thing we're talking about, guys, is that you know, this coronal hole. You see it right there. Okay, and what they're talking about with this one right here, they've actually issued a geomagnetic storm warning. They're expecting this to start on the 24th. Okay, we got a couple decent smacks on our magnetosphere today. It wasn't constant, but our solar wind increased. We seen a hit. Yeah, and Scott did a little video on it, about 3 or 4 minute video. Yeah, he shows it, and we definitely took some hits. Okay, but anyway, this is why. And here in the next day, they're saying we should get possibly up to a G1 class, maybe even a G2. I would say, if things. It's hard for them to like forecast how strong this is going to be and be very accurate with it, because I've seen them say, don't worry about nothing, we're not even going to get to storm level. And then we get to storm level and we stay there for like a day. It's crazy. And then the opposite will happen. We'll think we're going to get smacked around a bunch, and we don't get nothing, which is simply what happened like the past couple days, because we've been getting these coronal holes rotating through. And I'll show you the geomagnetic storm level here in a minute. It was virtually bottomed out, nothing. Okay, and we'll talk about that in a minute, but you can see the solar wind here. It's just illustrating it. So, you know, then they talk about the auroras. I put that in my forecast models, the update models I do at the end of my videos, but this is a little different right here. This is just showing you where you would be able, possible areas of aurora extent to the vicinity of the green lines, what it says. That's where they think it's going to stop this time. Okay, so you might see some down a little bit further, but they're not predicting that to happen. It would have to, in other words, the storm would have to be a little stronger than what they think it's going to be. Because if you look up here, it says G1. Let me do this real quick. Okay, it says G1, KP of 5. So when we have a geomagnetic storm level of a 1 and a KP of 5, which is basically saying the same thing. It's not exactly technically, but that's pretty much the same number. And again, guys, think of these of like thunderstorm elevation warnings and watches. Okay, as the number gets higher, the chances of seeing these things and the more effect that we have, obviously, is there. So, but in order for the auroras to show up where the yellow line's at, we would have to get at a G3 storm, KP of 7. And then for the red line, obviously, that would be a big storm. That's like a G5. And we would see it, well, yeah. I mean, you would see it down into the Carolinas. Looks like close to it anyway. Virginia. Straight through Nebraska, close to Oklahoma. So I just wanted to show that to you. I thought that was pretty cool. Okay, guys. Got you over here at Space Weather Prediction Center. Okay. It's showing you all the space weather conditions right now. As you can see, the solar wind is at 347, and we're not at any kind of storm level. Okay, there is no storm going on. You look at this. Okay, they're predicting right now, like I just showed you, late in the day on the 24th, we should be jumping way up to there. Okay, that's what they're saying. Now, I was seeing some hits on the magnetosphere today. Like I said, Scott made a video of it, and he showed it all too. But our geomagnetic storm level didn't rise hardly at all. It barely even came off the needle, right? So that goes to show you that we can still take hits, but it doesn't necessarily cause a geomagnetic storm. That means that we were able to deflect it, and it did not get into where we're at. Okay, it didn't make it past our shields enough to affect us big time. Okay, and like again, that's what I'm trying to say, guys. There's a whole lot of factors there. The density of the wind, solar wind. Okay, the charged particles that comes at us, the speed of it, all that stuff plays a part. So I just wanted to point that out and show you that, hey, look at this. This is crazy. I mean, this is extremely low, is what I'm trying to say, and this is not really what we want to see. I mean, we don't want to see huge geomagnetic activity, but about a 2 or 3 would really be kind of nice. But anyway, this right here is the ace, guys. And again, look at this. The solar wind is just flatlined. This right here, you see these little popcorns, what I call popcorn? That's the hits that we took. You see, because of that little dot right there, those little dots, those are all individual data points. Okay, so at that specific time, our solar wind was that high. Okay, the velocity of the wind. That's what that's showing you. And you can see the kind of popcorn going on. But the rest of it seemed to be pretty holding constant and actually very, 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 very quiet. And the same thing with the density. The density dropped out to nothing. Okay, it seems like it might be starting to rise up. So we might be getting ready to get these solar winds that we've been talking about. Okay, but right here, you see where they're popcorned everywhere here? That just couple different, I think it's a few hours there. So we did get an increase, and that's where we got these hits on our magnetopause, our magnetic shields. Okay, and again, the phi angle did its thing once right here too. Most of the time when you see that, we'll see a little jolt on our models. It'll pretty much show it. But anyway, and again, there's an Enlil. I'm not going to go through all this, but there's that other aurora forecast. I put that in my models. It shows it really well also. Okay, guys, this is a Schumann resonance. Okay, about probably a month or two ago, we were talking about this. Okay, we were seeing spikes on it, right? Those big white parts of this graph, you would see it spike up. You know, would do one of these numbers. That'd all be white colored. Okay, we're not seeing hardly any of that as of late. Matter of fact, it looks extremely normal. Okay, other than, this is what I want to talk about here. See this black line? That's missing data. This is missing data. This out here just hasn't happened yet, so we don't know what's going on there. But this right here, that's a big block, and we've been seeing that over and over and over again the past few weeks on this tool. Now, I can tell you from all the times that I've been watching this, which has been over a year, going closer to 2, and prior to that, I've talked to other people that we very seldom would ever see missing data on this tool, and now it's like all the time. Okay, and that's been part of the conversation here anyway. Scott's been talking about it. I've been talking about it. Everybody actually has been talking about missing data across the tools. So yeah. I mean, we can say or do whatever we want to talk about on this, but I do think that some of this is technical stuff, flaws that's happening. But other times I do think that they are killing these tools off for a minute, not letting us see it for whatever reason. Okay? And it's happening more and more often. Now, why do I think that they're doing that on purpose? Because it's happening at the same time frame on different tools at the same time. Some of these, like this human resonance tool, has nothing to do with seeds. Okay, nothing. This is a Russian tool right here. Okay, seeds is over here in America. Okay, that's the agency that runs it. That's what they do, right? The whatever agency over in Russia that posts this graph, obviously is over there. They don't have anything to do technically with each other, but yet their tools are going down at the same time. So what's going on with this? Okay, this is what we've been talking about for quite some time now. Now, like I said, seeds is not, and I'll show you. Hold on a second. Just remember, that's missing data. The rest of it doesn't look bad right there. Okay, well, our code thing that I've been calling it a code. I'm not sure if it is. I'm just saying that's what it looks like. Again, there's no way I could crack a code or something like that. I'm just saying it looks like it could be. But anyway, remember the missing data and stuff there. Okay, guys, look, this is seeds. Look right here. 2 days of missing data. At the same time, the human was missing data. Is that a coincidence? I don't think so. I really don't. I think something's going on, and I'll show you something else. Okay, guys, this is the SWMF models. Okay, this is the ones that I show you guys a lot on ISWA. Okay, because it gives you the time lapse. This particular site gives you just a single capture, like every however many minutes. Okay, but it shows you all of them. Okay, now this right here, like I said, I'm not even talking about the graph itself. Okay, but what I want to talk about is, well, first off, you see this right here, the Southern Hemisphere one here on the right. I can't tell you the last time I seen that thing when it was all blue like that. Okay, that just means that it's lower in intensity. And you see the black right there in the middle? We very seldom see that. That's a very rare thing to see. Okay, that means it's almost virtually no anything right there. Okay, and the Northern Hemisphere is showing the same kind of stuff. It's just not as the same. It's just not as intense. But anyway, here's the graph, okay? The top is the density. The second one there is the actual solar wind speed, okay? And if we want to see solar wind speed here too, also we can right here. 438. That's 438 kilometers per second. All right. Now down here is what I want to talk about. Okay, this is showing you the data points for the GOES satellites, which is where this tool gets its data from. Now, when you see these voids, that means that there was no data there. And as of late, we've been seeing tons, like in a pattern. And what I mean by that, if you go down here to the electric potential difference model, look at it. Okay, there should always be a red and a black on every timepiece. When you don't see a red and a black, that means it's missing data. Okay? So you can see how it's missing tons of data, and then it looks like it's trying to, for whatever reason, it looks like it might be trying to get a little bit more consistent. That's more consistent than I've seen it in a very long time. But again, this is the same time that seeds is down, the same time that the Schumann's screwing up. Okay? And this has been happening, all these tools do it at the same time over and over and over again. And I just don't think it's a coincidence. Because the Schumann's not getting its information from these ghost satellites. But yet both tools are not showing anything. They're missing the data. Okay, guys, we're going to talk about earthquakes real quick. Then we won't probably end the video. We're seeing an uptick, big time uptick. Okay. And I'll show you a map here in a second. But most of the earthquakes that are happening right now are actually happening on the fault lines, which isn't so much out of the ordinary. But yeah, it seems like everything's upticking right now. Now you can see there's one in Fiji. The one I really want to talk about is down here. This happened over in Ascension Island. Okay, sorry about that. That was a 6.4. Okay, that's a decent sized quake, guys. So, and it did happen right on the fault line. It was not deep at all. It was about 10 kilometers. At first, USGS had put this up as a 6.5. And actually was showing 3 different quakes pretty much at the same time. It was like a 6.5, 6.3, 6.5. Okay, like run right after another about the same time. What that is it's just them kind of, the tools themselves are picking it up. And I'm not sure exactly how they go ahead and decide which was the actual quake that started it or how they differentiate that. But regardless, there was some shaking going on there. Okay. And again, like if you scroll down through here, guys, you see a bunch of high 4s, 5s, and 6s. Okay, that's definitely an uptick than what we've seen. Now, again, we have not had a 7+ yet. All right, the last one was July 14th, I believe. So you put that, I think it's 100 days or a little over 100 days now without one. We're supposed to get them every 20 days. So we're way overdue. Just keep that in mind, because like I said before, we got this. Now they're saying geomagnetic storm warning. So when that stuff happens, also that increases the earthquake risks. Okay. So what I'm gonna do is I'm gonna let's take you over here and just give you the map here. Okay. I'll do the settings. All right. Let's do. Yeah, it's good enough. Okay, so I'll just zoom out here, but you can see them. Okay, the red lines, guys, those are fault lines. So you can see how most of them are hitting right on the fault lines, or close to it. Now, the red one here probably is the one that just happened. A lot of times that's what these things do. But here, the one that Ascension Island, guys, is the one out here in the Atlantic, off the coast of Africa there, kind of out in the middle. I always think it's suspect when we see those kinds of things right close to the South Atlantic anomaly, which is a shield anomaly. The shields are weaker there. I don't think even compasses work there. I could be wrong on that, but I think they get kind of jacked around because of the magnetics there aren't the same as what it should be. And it's just not a extremely large area, but it is. Just Google South Atlantic anomaly, and you'll be surprised. I might talk about that in a separate video. But look at that, okay? That's just one day. So you can see what's going on. But yeah, guys. Yeah, I was gonna show you the models, but that's just gonna take too much time. So if you want to check out those models, I did put it in my model update. And again, Scott did a video specifically showing the hits we took. But it did not raise our KP or our geomagnetic storm level. Usually when we get hit like we did, because we got fast solar wind and high dense wind, usually it raises it some, and it didn't seem to do that this time. Now, there's a whole lot of theories behind that, and that's another video, but But anyway, I'm going to give another shout out there to Johnny in Montana. GT for y'all. Thanks for putting the comment down there. And hope everybody has a great week. And God bless. Yeshua saves. And you can drink this Kool-Aid.
Give it back. used to say, live and let live. You know you did, you know you did, you know you did. But if this ever-changing world in which we live in makes you give in and cry, say live and let die. it's a million